Hello everyone, welcome back to Cambridge Guru. In the last video, we talked about recurring decimal and finding out its rational equivalent. Okay. In this video, we will be talking about what is called as prime factorization of a given number. Okay. So let us start. Get your pen and notebook ready. We will solve some questions also. Right. So start making notes. So here is the topic that to express a given natural number as a product of prime factors. So in this statement, in this heading, the important thing is the number, whatever number we have been given, that number should be a natural number. We cannot find out prime factors of negative numbers. Okay. Then the important thing or word in this is factors. Most of the students, they find it very difficult in understanding the word factors. It is very easy. Factors means the numbers which divides a bigger number. For example, if I talk about 12. So what are the factors of 12? Meaning is what numbers divide this number 12. So we start from 1 because 1 is a number which divides 12. There is no doubt in it. Then 2, 3, 4, 6 and then 12 also we need to include because a number can always divide itself, right? So these are the factors. These are the numbers which divide the given number 12. So what are prime factors? So as the name suggests, out of these 6 factors, we need to choose the prime numbers which divide this 12. So only the prime factors of 12 are the prime numbers. So as we know, the prime number, the basic or the starting prime number is 2. So only 2 and 3 are the prime factors of 12. Okay. Now this 12 can be written as a product of the multiplication of, or it's some same thing, as a product of its prime factors. So instead of writing this 1, 4, 6 and 12, as you can see, 4 can also be written as 2 into 2, 6 can be written as a multiple of 2 and 3, and 12 can be written as a multiple of 4 and 3, meaning 2 square into 3. So meaning is we can write down any given number as a product of its prime factors. So this 12 can be written as 2 square, which is 4 multiplied by 3. Right? You can take another example. Suppose this is your example 1 and let us say example 2 is 36, you can say. Right? Now the method of finding out the prime factors is, I think you have learned this in lower classes. So I'm repeating this. So 36 you write like this, and what we do is we start dividing by the first prime number, which is 2. So we start with 2, divide this 36, we get 18, right? And then again this 18 can be divided by next prime number, not next prime number, this 18 can also be divided by 2, we get 9. Now 9 is not divisible by 2, so we switch to the next prime number, which is 3. So this goes with 3 and 3 goes with 1. That means this 36 can be written as 2 into 2 into 3 into 3. So as you can see, this 36 can be written as product of prime numbers, and not to be more precise, not just the product of prime numbers, but the exponents of the prime numbers, right? So this 2 can be written as 2 into 2 can be written as 2 square and 3 square, right? So 36 is 2 square into 3 square, and this is what exactly the fundamental theorem of arithmetic says. It says that any natural number can be written as a product of its prime numbers. And when I say the product of its prime numbers, means the product of the prime numbers including the exponents of the prime numbers. Means there can be the same prime number which can be a factor, right, multiple times. Okay, so this is about finding out the prime factors of a given number. Okay, you start dividing the given number by the first prime number and keep on changing the prime number as soon as you get a number which is not divisible by the first prime number. So you switch to next prime number. Okay, we can take another example. Let us say example number 3. Let us say 96. Okay, so start dividing 96 by 2. it goes 2 times, 48 times, sorry, and then dividing by 2 it goes 24, then again 12, then again by 2, 6, then again by 2, and this time is only 3. So this 96 can be written as a product of prime numbers raised to some exponents. So here you get 2, how many times you are getting? 1, 2, 3, 4, 5. So 2 raised to power 5, which is 32, multiplied by 3. So 96 can be written as a product of prime numbers as 2 raised to power 5 and 3. Okay, so here you will notice that only the prime numbers are the factors. So it is slightly different from finding out just the factors. It is about finding out only the prime factors, meaning the factors which are prime numbers. Alright. Now, the application of finding out the prime factors is to find out the HCF and LCM of given numbers. Okay, so this is the prime factorization and its application, that it can be used to find out the LCM and HCF. Okay, this also you may note it down. All right, so what is HCF or highest common factor? As the name suggests, we need to find out, we have been given two numbers, let us say 60 and 90. We need to find out the factor of both 60 and 90. That is the meaning of this factor. And that factor must be common to both 60 and 90. That's the meaning of common. And also that common factor must be the highest common factor. That is the meaning of highest common factor. Okay. This explanation looks very easy and very simple. That what's the difference of explaining this word by word, and that is the meaning or difference in understanding. Okay, highest common factor, because if I ask what do you mean by how, or what do you understand by highest common factor, most of the students, they get confused in explaining the difference between the LCM and HCF. Okay, so we need to find out that factor which is common to both 60 and 90, and that must be highest. So the first method, or not the method, but the first step is to find out the prime factors of both 60 and 90. Simply speaking, noting down this 60 and 90 as product of its prime factors. So as we know that 60 can be written as 15 into 4, meaning is 2 raised to power 2, this is 4, and 15 can be written as 3 into 5. Okay, I'm just skipping that long division method since I know the factors of 60 and these are simple numbers. So after that long division, the important step is to write this 60 as the multiplication of prime factors like this. All right, then 90 also can be written as a product of prime factors, since I know that 90 is 18 into 5, and because 5 I get one prime number, and 18 can be written as 9 into 2. So here we have 90 as 2 into 3 square, which is 9 into 2, 18, and into 5. So in 90 also, in this representation, we can see that only prime numbers are there. Okay, so this is the representation of 60 and 90 as a product of their prime numbers. So far so good. Okay, now highest common factor says that we need to find out the least exponent of the common factors. This pictorial representation will make you understand this concept very easy, that noting down the prime factors of 60 and 90 and writing down the common numbers. As you can see that 235 both are in 90 and 60. So we can write these numbers in the middle. Okay, in 60 we have an extra 2 here, as you can see. Let me show this with the laser. As you can see with this laser red dot, that this extra 2 in the exponent is for 60, so we will write down this 2 which is not common to 90. And similarly in 90 we have this extra 3 which is not in 60, so this lies outside the common portion of 60 and 90. Okay, So this portion is for 60 and this portion is for 90. And as you can see, the common numbers which are lying in 60 and 90 are 2, 3 and 5. So multiply these two numbers, you will get HCF as 30. This is your answer. Okay. HCF as 30. I should write down here. Okay. So the thing is, as you can see that name suggests highest common factor. Let us understand the meaning of this answer. We get answer as 30, which is less than both 60 and 90. Okay. So highest common factor, whatever is the answer, that will always be less than or equal to the given number. It cannot be greater than the given number. First thing is this. Since 30 is our answer, so let us understand in terms of highest common factor. It says that it is the factor of both 60 and 90. It is common to both 60 and 90 because 30 divides 60 and 30 divides 90, and this is the highest number. Although 5 also divides 60 and 90, 10 also divides 60 and 90, 15 also divides 60 and 90, right? But the highest one is 30. Okay, so that is the meaning of HCF, right? And how we will find out? By writing the given numbers in terms of its prime factors and its exponent, is to find out the common factors with least exponent. Common factors with least exponent. Okay, it is common factors with least exponents. And what we need to do with these, we need to multiply. So in fact, it is multiplication of common factors with the least exponents. Let us relook the common factors. We have 2 raised to power 2 and 2 raised to power 1. So least exponent in this is 2 raised to power 1. That's why we took only 2. In 3 and 3 square, least exponent is 3 raised to power 1. So we took only 3. And in 5 raised to power 1 and 5 raised to power 1, least exponent is just 5 raised to power 1. So we took only 5 raised to power 1. Okay, so multiplication of the common factors with least exponent, you will get the answer as 30. Okay, just pause the video, or you may rewind this video in order to look the concept of finding out HCF using the exponent concept. Let us move further with the second application of prime factorization, which is LCM. Now in terms of these wordings, it says the multiple. Now we are not interested in finding out the factors, we are interested in finding out the multiples of the given numbers. So again, we took the same numbers as 60 and 90. Okay, and we will think in terms of multiples of 60 and multiples of 90. So you start writing or thinking about the tables of 60 and 90. So the next number multiple of 60 is 120, next is 180, right? Then 240 and so on. And similarly for 90, next multiple is 180, then 270, then 360 and so on. Out of these multiples of 60 and 90, which one is the least? Answer I think you got, which is 180. 180 is the multiple which is common to both 60 and 90, and it is the first multiple which is common. Although 360 is also a common multiple of 60 and 90, but that is not the least, right? So we are not going to find out LCM of given numbers like this. This is a part of your checkpoint 6th and 7th or lower secondary syllabus. We will deal with the exponents. So same thing we will do. We will write both 60 and 90 as the multiple of its prime numbers, like this, that 60 was 2 square into 3 into 5, and 90 was 2 into 3 square into 5, right? So in terms of exponent, we need to find out the LCM, and that LCM will be the multiplication of common factors this time with highest exponent, right? So as you can see here that we have 2 raised to power 2 and 2 raised to power 1. So the highest exponent of these two common factors is 2 raised to power 2. So we will multiply not 2 but 2 raised to power 2. And then next factor is 3. Its highest exponent is 3 square. First we will find out the common prime factors, which are 3, which is 3 in this case, and then we will look for the highest exponent. So 3 raised to power 1 is here, 3 raised to power 2 is here, so we will choose 3 raised to power 2. And lastly, there is exponent of both 5 is 1, so we will take just 1. Okay, so answer in this case is 180. Okay, 9 into 4, 36, 36 into 5 is 180, right? So by logic also we arrive at the solution 180. Okay, and by this exponent exponent logic, we arrive at the same solution, and that is the beauty of maths. Okay, fine. So let us summarize how to find out HCF and LCM. You may take the picture of this, calculating HCF through prime factorization and exponent. So it says that breaking down the number into their basic prime exponents, then identifying shared elements in the prime factorization, that is finding out the common factors, and then selecting the minimum power of the common factors. This minimum is for finding out the HCF. Okay, same figure is for LCM, but only one thing that makes a difference, which is we need to select the highest or the maximum powers of the common factors, right? Let us take the previous example. Let us say we have another number, or for example there is one number which is 7. Let us say, okay, instead of this 60, let us say I take 420. So prime factors of 420 will be like this, that I multiply this by 7. Okay, so let us remove this. Okay, this is in addition. Okay, so this 420 can be written as a product of its prime factor like this. Now we need to find out the HCF. So HCF, as there is no 7 here in 90, answer is no. I mean 7 is there, but it is written like 7 raised to power 0, which is 1. This is very important, right? I am repeating that this 5, there was no 7 here, so I can say that this is in fact a multiplication of 1. We can multiply 1 to any number, answer will remain same, and this 1 in fact can be written as 7 raised to power 0, because something raised to power 0 is 1. Okay, now why I have done this? In order to find out the common prime factors, okay, and dealing with the exponents. In case of HCF, this 7 is here with 1 exponent and his 7 is here with 0 exponent, so we will take the least exponent. So HCF will remain same for both 420 and 90, because common factor will again be 2, 3 and 5, and exponent we will take as the least. So for this HCF will be 2 raised to power 1, 3 raised to power 1 and 5 raised to power 1, or you can take 7 raised to power 0 also, which in fact is 1. But as far as LCM is concerned, answer will change, because we will have to take 7 also, the highest exponent, right? So 2 raised to power 2 will take, then 3 raised to power 2 we will take, then 5 raised to power 1 we will take, but this time we need to take the highest exponent of both 7 raised to power 1 and 7 raised to power 0, which is 7, Okay, so this 180 multiplied by 7 will be the LCM. Okay, so this is one difference, a little bit complicated. Okay, you need to keep this in mind. All right. Now, important thing in this is very important. You may note down this statement that if we have to find out the LCM and HCF, not find out the relation between HCF, LCM and the given two numbers, that the product of the given numbers A and B is equal to the product of the HCF and LCM. We take the same example of 60 and 90, right? So 60 and 90, if I multiply these two, I will get answer as 5400. Okay, and if I multiply the HCF and LCM, HCF was 30 and HCF was 180. So again you will get the answer 5400. Meaning is that 60 into 90 in fact is equal to 30 into 180. Meaning is it satisfies this equation or the relation. So for any given two numbers, the multiplication of two numbers is equal to the multiplication of HCF and LCM. Okay, so that's it. In the next video, we will solve a couple of questions related to HCF and LCM. Thank you.